Hi everybody, this is R-Arunakritika and I am going to talk about inline functions in C++. Now inline function is a special command that is given to the compiler at the time of compilation. Let's see how it works. Now if any function is written using the keyword inline, we term that function as an inline function, right? The compiler places a copy of the code of the function at the point where the function is called at the compile time. So this is what is being done. So any function that is written inline during the time of compilation, the compiler copies the piece of code and places it wherever we call the function at the calling position, right? Now let's see the working of the inline function, right? If a function is inline, then the compiler replaces the calling function location with the definition of the inline function at the compile time. Any changes made to an inline function will require the inline function to be recompiled again because the compiler would need to replace all the code with a new code, otherwise it will execute the old functionality. This is obvious, right? Now once we try doing any corrections in any piece of code in C++, it is a must that it should be recompiled. The data should have been saved priorly and it should be recompiled so as to carry out the latest corrections that we have made on with the code, right? When the program executes a function call instruction, the compiler copies the program function's arguments to the stack, catches the memory address to the next instruction, and then hands control to the targeted function. So this is what actually happens in memory. So the code that is being written using the keyword inline will be stacked in memory, and the location of that particular stack, the address location will be copied to the code in the program wherever we have called for this inline function, right? Then the CPU then performs the code's functions code, okay, saves the return value in a designated memory address or register and hands control back to the function that is called the function that is calling the inline function. So memory the code of the inline data will be there in memory. Only the address of that particular memory location will be substituted everywhere whenever you try calling the inline function. That is number one. Then number two, what happens while execution is that, so the code executes, the inline code executes the data, saves the results and return back the results wherever the inline function is called. Alright, so this is how it starts working during the time of compilation, right? This may become overhead if the function's execution time is shorter than the time required to move the calling function to the called function. That is, callee and caller between data transfer between caller and callee function will be fast and effective only if the function that is called is shorter than the complete compilation time of a program. Okay, if the compilation time of the program is even more lesser than calling this functions to and fro from the inline to the targeted code and etc., then it really becomes a overhead. Okay, then there is no point in making use of this inline function at all. So it is a must that we'll have to see that the function that is defined inline should be very shorter. It should take shorter time period for execution and the transportation of data to and fro, right? So then we'll move on. The overhead of the function call is typically negligible compared to the length of the time required to run large program or complicated functions. The time needed to call a small frequently used function, However, is often far longer than the time necessary to run the function's code. Due to the fact that their execution time is less than switching time, tiny functions experience this overhead. This is what we were explaining earlier. So the time for execution of the inline function should be very shorter. Only then the code becomes effective. Okay, while using this inline functions. To minimize the overhead of function calls, C++ offers inline functions. Okay, when a function is invoked, it expands inline and it's known as an inline function. When an inline function is invoked, its entire body of the code is added or replaced at the inline function call location. This is what we were trying to explain all this time. Okay, so the code written using the keyword inline will be replaced wherever it is being called. Right? At the time of compilation, the C++ compiler makes this substitution. Okay, efficiency may be increased by inline function if it is tiny. Right? To the compiler, inlining is merely a request and it is not a command. So you try requesting the piece of code to be attached wherever the calling function is being done. Okay, there are some limitations uh, for using this inline function. Let's see what are all those. The compiler may not implement inlining in situations like these. If a function contains a loop, if a function has static variables, whenever function recurses, if the return statement is absent from the function body and the return type of the function is not void, whenever a function uses a go to or switch statement. So under these conditions, it is better not to use inline functions because to reduce overhead of the code's execution time. Okay, let's see the syntax of inline function. So inline function is written like this. We make use of the keyword inline, return type of the function, name of the function, and of course parameters if any, right? And the function code. Now, here is an example of using the inline function. So we have used a inline function, the keyword inline, return type int, name of the function add, and it takes two parameters a and b. Now the function is going to return a data, that is both the parameters a and b are added and the added data is being returned. Now inside the main method we try to call this inline. So look at this, there is an output statement where we have appended the function, that is the inline function add of 2 comma 3. So we'll try to make use of this code to show how inline function works. Let's see. See, after the compilation of the prior code, now the code becomes, instead of calling this add a comma b, that is 2 comma 3, see the compiler has replaced the code of the inline method by itself. So what is the code written here? We have tried to return some data, return a plus b, that is we have given a actual parameters here, return 2 plus 3. So this is how your compiler tries to replace the program code wherever it is being called. So this int main is the callee function and the inline method called add is the calling function. So it tries to replace the calling function wherever it is being called. Excuse me, wherever it is being called. So this is how inline function works. Need for inline functions. We'll take a quick look on the need for inline functions. Whenever a function is called, it takes a lot of time to execute the task, such as moving the calling functions to the called functions and again. Okay, so if we try calling it a number n number of times, so n number of times the data has to move to the calling function and the called function. So this execution time overhead will be there. So if the length of the function is small, then the substantial amount of execution time is spent. in such overheads, and sometimes time taken required for moving to the calling function will be greater than the time required to execute the function. So execution of the function becomes lesser than calling time taken for calling the function. So in such cases we try to use the inline functions. Hope this video would have been useful for all beginners of C++ to understand how inline function works. Thank you.